I'm very pleased to introduce to you our first keynote speaker for this afternoon, Dr. Naba Barkakati. Dr. Barkakati is the Chief Technologist for the Applied Research and Methods Division at the U.S. Government Accountability Office, GAO. He leads the GAO's efforts to evaluate technologies such as U.S. federal government software system and enterprise architecture. 네, 자, 지금부터 기조 발표를 시작하겠습니다. 네, 첫 순서로 GAO의 Chief Technologist인 나바요티 바카카티님 박사님을 모시겠습니다. 네, IT를 통한 새로운 비즈니스 모델 창출이라는 주제로 네트워크 인프라와 IT 융합을 활용한 다양한 부분의 기업 경쟁력 강화와 생산성 향상과 같은 혁신적인 솔루션 사례와 향후 BM과 IT 융합의 산업 확산 전망이라는 주제로 30분 동안 발표를 해주시겠습니다. He is currently leading the evaluation of explosive detection system. Please welcome him a big round of applause.
Good afternoon. Well, I hope we had a good lunch, and I'll try to keep myself, within the time, and hopefully exciting enough that you won't have to, feel lethargic after the good lunch. I'm going to spend the next. First of all, let me start by thanking KISDI for inviting me to give this keynote speech, and for giving me the honor to speak to this distinguished audience about IT convergence and IT solutions for new business. I think I hope to provide, I know that we are probably going to, when I finish, you'll probably feel that I'm talking about the similar things as all of our other speakers. But at the same time, I hope there'll be something new from my perspective of working as a chief technologist at the Government Accountability Office, where we look at other US government agencies' adoption of IT technologies and any new trends that come up, including IT convergence, and that gets reflected in those agencies' systems, which we go and look at. So from that perspective, hopefully, I'm going to add some value to this. Well, when you talk about convergence, of course, we are generally referring to what Nicholas Negroponte of Microsoft, MIT's Media Lab long ago had referred to the transformation of atoms to bits, the fact that all information, voice, video, data is coming together in digital form and across networks to devices and PCs to people's hands. And the most common, I guess, manifestation of this convergence is where we see on the hands of the consumers today, the smartphones where you can go ahead and use the phone for anything from voice calls to taking pictures to video to providing a hotspot, Wi-Fi hotspot for other devices and many other uses. That's where we see the result of this IT convergence that we're going to talk about in a little while. Now, before we talk about the future of IT convergence, I want to focus a little bit on the history of it. I think, they say, those who don't study history are doomed to repeat itself. This is probably a good example where we need to look at what facilitated this convergence over time, and maybe from the lessons of what has gotten us to this point, we can learn and adopt similar ideas for future so that we can keep a good thing going for the future. Now, I would start with this maybe about 1990s when Sun Microsystems, they had adopted this phrase called the network is the computer. That was used to be in advertisements all the time at the time, And they were, of course, that phrase probably is just the right time to think of as a starting point where you might say, well, convergence, the idea of convergence that had emerged and was beginning to grow. And at that point in time, the conditions were just right for the IT convergence to appear because the microprocessors, the processing power of the microprocessor from about 1970 onwards has been doubling every 2 years, and that was like the Moore's law that as we know it. We had the network in internet connectivity emerging, and in fact, one of the side issues I want to point out is this network layered model. The the 4-layer simplified model for TCP/IP, where you see that that was a very conceptual breakthrough that was also played a great role in facilitating the network connectivity that we nowadays take for granted, with its every layer with its own protocol, information flowing down from application layer down towards the physical layer, going to other systems, and coming up to applications on another system. So application-to-application connectivity with this network layered model has been one of the major factors as well in that early time to facilitate the development of internet. And of course, as I'll describe a little later, this concept of network layered model comes up in discussions of network neutrality, or even virtualization, which is another term you have heard mentioned earlier, and plays a big role in some of the things I'm going to talk about. And then of course, among those protocols that I mentioned, you had HTTP, the hypertext transfer protocol, which is for web transfers between web server and web browser, HTML format. There's a whole host of other things that are behind the scenes that enabled us to have all the connectivity that we have seen since the days of mid-1990s. Now, sorry, I think, oh yeah, I forgot. I was going to also bring up one more item. One element, at least in the United States, that was a facilitator for the convergence was the Us Telecommunications Act of 1996. The reason I bring this up is, of course, before this act was passed, for about 64 years, there was no change in the US telecom regulations, and it was designed for voice telephony, old times. When they had done this law, passed this law in 1996, the idea was to encourage competition among all types of, primarily in the same mode of communication, like telephony, was local, long distance. It was designed for competition in those areas. And it also gave a task to the Federal Communications Commission, which is in United States, that's the agency that regulates spectrum and telecommunications regulations. They were tasked to promote broadband adoption in the United States. So they did that by classifying the internet connectivity as an information service, which required less regulation. They reduced the regulation on that, and that was a big facilitator, in fact. Now, their goal was to promote, as I said, voice over switched network, switched circuit network, and local and long distance. But what resulted after this act was more of a intermodal competition between different modes of communication, among wired versus wireless, and also voice over IP over wireline and wireless communication, IPTV and cable TV. And so in the end result was we had a bundled services that emerged. From my own personal experience, within the last maybe 5-10 years, we got these bundles of services that were offered by different companies. Maybe someone who has connectivity to your home through cable television, they offer voice, video, internet, usually, as a bundle, offered by telecom companies like Verizon or cable companies like Comcast. And that really promoted to the connectivity to the home greatly. With all these factors coming into play, of course, what we saw was the emergence of this internet business model. Now there was connectivity to people and businesses, and there were businesses who wanted to take advantage of that to do business, in terms of selling things, for instance, ideally in the beginning, online commerce, Amazon.com. These are some of the household names, probably worldwide, mostly at least in the United States. Auction, like online auction, eBay, search engines, Yahoo, Google. Now more recently, the social networking, Facebook, Twitter, etc. So these have, of course, caused businesses to look at the internet as, some kind of internet business strategy as a routine matter of their existence now. And for instance, most businesses today would always consider having a website, maybe online commerce of some sort for selling things. They would probably have presence on Facebook, Twitter, other social media. They would be taking into account like search engine optimization to make sure their website or their company comes up first when they search for the right terms, on the web search like Google or Yahoo. So those things are taken on as a very routine matter of business strategy for any business that's working today. But now, moving on to the core, area of the discussion for this last 15-20 minutes of my time, it's the focus on the convergence of IT together with the network infrastructure. And by network infrastructure, we mean the internet, internet infrastructure. What we see is that that's giving rise to what we call cloud computing. And virtualization plays a key role there too. Of course, what is happening is data centers that are built in the core of the internet with good connectivity, large-scale data centers can now offer, if you have connectivity to them, you are easily able to access their services, the computing power, in terms of either running applications or just renting the facility for storage or for developing application. I'll talk a little more about it in a little bit of time. But as I mentioned earlier, one element that has played a key role is this virtualization concept. And this also, you'll see, it's like a similar layered model idea. You have the bottommost layer where you have the physical hardware devices of a server, the CPU, memory, disk, etc., network card. Above it, you have a virtual layer, abstract layer. And then above that, you can have actually operating systems, different operating systems, running in different machines that are virtual machines, each with its complete, virtual hardware, operating system, applications. And this is kind of the crux of also one of the, reasons why we see the growth in cloud computing, because now you can suddenly have maybe one powerful server can support maybe 60, 20, 30, depending on how it's configured, multiple numbers of virtual machines. And you can rent your, one of those virtual machines or multiple of those to do computing if you need to. So that's one of the facilitators as well, the virtualization of cloud computing. Now, as far as we had looked in our Government Accountability Office, we had looked at the cloud computing adoption by US government and, of course, government agencies. And we have an organization called NIST, which does standards. And they had defined some concepts for cloud computing. The two elements to remember. One is the service model and how the service is purchased from the service provider. The second one is the deployment model, how the cloud is built and organized and implemented. So I'll cover both. First one, the service model. If you look at the line I draw here, see the three layers here: infrastructure, platform, and software. Infrastructure is the hardware, the servers, maybe the virtual machines. The platform level would be like an operating system level, and maybe you're buying Linux operating system level with programming languages that you choose. And above that is application level. At that point, you're buying basically you're trying to get time to use applications. Like trying to, for instance, even though the concept of cloud computing sounds new, well, we had Salesforce.com, who has this customer relationship management application where you can rent time and buy, to use it. They were offering it as a software as a service since like 2007, I think. So if you draw the line at the infrastructure level, you get infrastructure as a service. If you draw the line at the platform level, one level up, you get platform as a service. And if you take at the level of the software, it's software as a service or application as a, application service provider or things like that, other names that come up. So depending on what you need, depending on your business type, you can select the level of kind of service that you want to buy from a provider. And in fact, by now, if you just search, you'll find Amazon Web Service. Amazon has the Elastic Computing Cloud or something, E2C, I think is the name. They even have the pricing there. You can buy a Windows machine. You can buy. You're buying the machine on the web, of course, and you can use it from your business, as if it's your own computer. But they have pricing models and all provided now, and it's kind of offered on the internet already. The next one, the deployment model, is just focuses on, because people have concerns, right? That if it is cloud, then maybe it's like out there somewhere. How would I control it? You might have an issue with the data where it's residing. So there is actually concept of private cloud. If you have a large organization, you could still, there are actually benefits, even though it sounds like, why would I do a private cloud if I'm running my own computing facility? But there are benefits that come with it, because it's kind of standardized the way the whole cloud computing idea has evolved. It may be still a good idea to have a private cloud for your own organization. Or you can have community cloud, which is multiple similar businesses could group together to share something. Like it's kind of shared among only the members. And then the public cloud, of course, is the internet-based, the one that I'm talking about, Amazon's web services or E2C, things like that. And then the last one, just for the sake of completeness, it's a hybrid cloud. Maybe you have a private cloud working with a public cloud, that sort of thing. So those are the two things. We got the service model, you got the deployment models. Now,